So good evening, everyone. We are going to start with the next algorithm today, next model, that is a decision tree algorithm. So as we already discussed, we have done with linear regression, logistic regression, and k nearest neighbor, three algorithms. Okay, so today we'll move to the tree-based algorithm. So initially it was the distance-based, right? Now it is a tree-based algorithm. In that we are going to cover the decision tree today. So it's a supervised machine learning algorithm. It falls under supervised technique, right? Supervised, unsupervised, and reinforcement. Three techniques are there. Among that, it will fall under supervised, used for regression as well as classification. Regression as well as classification. So for both the use cases, it will be used. It will be used for regression as well as classification. And there is a word called tree, right? So it will have a tree-like a structure. How it will look like? It will look like a tree structure which will grow from the roots. Okay, roots will be there, branches will be there. Those are called as the nodes. Leaves will be there, or leaves will be there. Leaf. So there is certain terminology that is used in a decision tree. That is it starts from the root node. It starts from the root node. Then it moves to the decision node. In between whatever there, that is a decision node. And last one is the end of a tree or end point of a tree, that is a leaf node, or sometimes called as a terminal node. So we will remember these three words, which are the root node, decision node, and leaf node. I will explain what is the meaning of each term, right? So root node, that is whatever data is with us. For example, we are having 10 features with 100 records or 100 records or 100 rows, we can say. So those will be provided at a root node. Then some decision will be taken on a decision node, whether we have to split it further or not. Tree will be like splitted further, right? It will have branches like this, correct? And whatever end point is there, so there that will give you the output. Final output will be based on the leaf node. So right now, just try to understand it's a tree-like structure. Decision tree is nothing but tree-like structure which will have three types of a node right now: root node, decision node, and leaf node, which is supervised machine learning algorithm used for regression as well as classification. And in between, some decision is taken whether we have to split further or not. That is based on the if-else statement. If is true, then split. No true, then go for the else. Like this, it will work. So you'll get idea about like whole decision tree through the session. Okay. So just try to pay attention, and if it is like challenging after that as well, we will discuss. Okay. So these points we are going to cover today. Introduction to decision tree. Some key terms are there. Just now we have discussed some of the key terms, like what is a root node, what is a leaf node, what is a decision node, then what is mean by sub section of a tree or branches. Okay, how the decision tree works, what is the working mechanism behind the decision trees. Then there is an important thing that is called as information gain and entropy. Information gain, and one more term is there that is called as the Gini index. So on this basis, this is the criteria actually to split further or not, right? Suppose tree having some data over here, again it is split into two different subparts, and whether we have to split further or not, that is depend on this Gini index or entropy. Then we will move to the advantages and limitations for the decision tree. What are the real world use cases? How we can improve the decision tree performance, and then we will go for the implementation with the help of Python. So these points we will cover. Important points are working mechanism, key terms, and understanding entropy and Gini index. Entropy and information gain, those are like related to each other, but two different terms are there. We can say hyperparameters. You have a good idea about hyperparameters now, right? Yes, for k there will be two hyperparameter p and k.
Okay.
Like this will be two criteria, correct? There will be two criteria, that is the entropy and Gini index, in order to work with the decision tree. Now we'll understand what is this decision tree. It's a supervised machine learning algorithm used for both classification as well as regression. Even you are if you are predicting person diabetic or not, iris setosa, versicolor virginica type of a flower, you are predicting whether loan will be approved or not. And even if you are working with the prices, you are working with the sales value, sale cities, number of products sold, then this will work in both the cases. Decision tree will work for the regression as well as classification, which works simple on a nested if else statement, whether we have to split further or not. That's all. Okay, so majorly it is used in a data analysis. Like somewhere it will start, this start is known as the root node. This first start is known as root node. Suppose we are having some feature we are having a, like abc feature we are having, and it's simply asking different values will be there: 10, 20, 30, 11, 12, 9, 4, 5, 6, 7, 8. What it will give? It will work on some condition a greater than 10. Yes, those points will be like, suppose 100 data points are there for a. For a, how many records are there? 100 records are there. It will simply split these into the two different categories. Whatever a values are there greater than 10, those will be on one side, on right side it will be less than 10. So this is how it will work. Again, with those values, some other value will be checked. Some other feature is there, feature b is there, equal to red. If it is yes, then on yes side. If it is no, then on no side. Again, some third feature is there, which is again checked with the reference to the first feature, and it will give you the outcome. So this is how it will work. We'll try to understand it with the help of example. We are having some example over here, and with the help of example it will be like clear. Okay, don't worry about it. Just have patience for some minutes, and you will get a like overall idea about a decision tree. So it is used for both the cases, categorical as well as continuous data. So these are the two types of a data for a decision tree, which has a categorical variable target. So that will be a categorical variable decision tree, and continuous variable decision tree, that means your target is continuous, right? Price, sales, quantity. So these values will be calculated with the continuous variable. And if you are predicting diabetic, non-diabetic, okay, diabetic, non-diabetic, then customer churn is there, customer churn model is there, customer will stay with us or not. Then spam, not spam is there, email, spam and not spam. So for these values we will use the categorical one. Now try to understand the structure first. What is the structure, or what are the like key terminologies in a decision tree? Like initially it will have a root node which will represent the entire population. Entire population, that means whatever there, 1000 rows and 10 features are there, 10 columns are there, those will be provided at a root node. It is having tree like a structure only, just a tree structure. And this further get divided into two or more homogeneous sets. How it is divided? Based on some condition. So that is done with the help of a splitting. That node is splitted into two different categories, like decision node 1, decision node 2, like this, right? But it will apply some condition over here: age greater than 40, age less than 40, okay, blood pressure greater than 80, blood pressure less than 80, like this. It will work simply on if else statement. In two branches it will be splitted. Decision node means when sub node splits into the further sub node, then it is called as the decision node. So if node is having branches further, this decision node is having branch further, right? This decision node is having branch further, so it is known as the decision node, where decision is taken whether split or not. This is a final node, right? After this terminal node nothing is there, so this is known as the leaf node. last node of a tree. So after this there will be no splitting, right? After this there will be no splitting. So this will be a final node for a decision tree. So three types of nodes are there: root node, decision node, and terminal node. How it is stopping that splitting, that we will see. So for that it is calculating the entropy and Gini index actually. Okay, in order to stop that process, it is calculating Gini index and entropy in backend. How it is calculated, that part we will cover. Okay, so leaf node or terminal node, that is a node with no children or no further split, right? Parent children or like parent child relationship is there. Okay, so I hope these three nodes are clear. Any doubt in these three types of a node?
No, sir.
Okay, then there is some term like called as the pruning. What is mean by pruning? When we reduce the size of a decision tree, when we reduce the size of a decision tree by removing the nodes or opposite of a splitting, like we are cutting the tree. Suppose like 15 features are there, so your tree will grow infinitely. Tree will grow infinitely. To stop that process, we are using something called as the pruning. So it's just a cutting down the branches of a tree so that it will not be like grew in a like large manner. Okay, so in order to avoid the like increase in the size of a tree, what we are using? We are using a process that is called as the pruning. Branch or a subtree is nothing but subsection of a decision tree called as the branch or a subtree. And parent and child node are known as a node which is divided into subtrees called as the parent node, and no sub nodes are the child of a parent node, right? Parent child relationship is there. Parent node, that means a decision node, and leaf node, that is a child node. Is it okay for everyone?
Yes, sir.
Okay, next is how it will work. Right? We'll take some data and we'll try to understand it with the help of example. So decision tree works on a simple nested if statement. Nested if else means inside something, right? Something inside something. What is the meaning of a nested? Inside something, right? So decision tree breaks the data set into smaller and smaller subset, while at the same time it create a decision tree and result determined by the leaf node. So results are determined by the leaf node only. Results are decided. Results are decided with the leaf node only. How it will work? Decision tree like a structure used for the making decisions. Okay. So input data set we are having, right? We are having some input data set. House price prediction data we are having. Suppose what data is given? House price prediction data is given. We are going to train a model. Initial split, how it is splitted, size less than 1000 square feet. First feature is chosen. Okay, so choose the best feature. Which is the best feature choose? Size is the best feature that is chosen by the model. Create a decision node. Split the data at each node based on the feature. Size less than 1000 square feet. Yes, right? So some data will be there. Suppose 1000 records are there. How many records are there? 1000 record. It could be like 700 this side, 300 this side, right? Is it okay?
Yes, sir.
Right? Till now it's fine. Next, generate a leaf node. Okay, so for this 700, next is compared with the bedrooms. Number of features will be there, na? First will be size. Next, number of bedrooms are there. Then has a garage or feature, it will check. And then size is less than 1000 feet, bedroom is greater than 2, then go for the buy. How it is go for the buy? On what basis it will go for the buying? So there are two options, right? Now, suppose buy yes or no. Buy yes or no. So two choices are there. Buy yes or no. Bedroom greater than 2. Out of 700, suppose if it is splitted like bedroom, if it is yes, and out of this 700, how it will be splitted? It could be splitted like 300, 400. 300 yes, 400 no. Again, if it is split, if it is like checked with the number of bedrooms greater than 2. If it is like something 300 0, all are the yes and 0 no's are there, then it will go for the yes. If this situation is like this 0 300, so what will be the decision? We are going to rent the apartment, we are not going to buy it. So on what basis it is deciding? If I am having two categories, suppose these are there, yes, so it should be sub split. It should not be like this. Out of 10, 5, 5, 5, 6, 9, 1. So it is not splitted properly, right? There are 9 yes and 1 no. But if it is a 10 yes and 0 no, what is the meaning of it? It will go for buying.
No.
What is the meaning of 0, 10? It will go for
Go
rent, right? So it should be a split. That is decided with the help of entropy and Gini index. That part we will see now. So for that, what we are going to do, we are going to take one example so that you will get an idea how it will work and how features will be selected. So through this example, you will get everything. Okay. So everything will be like sorted with the help of this example. What we have to predict? What we have to predict? If John will play tennis or not based on the some climatic condition. 3 climatic conditions are there. Outlook is there, humidity is there, and wind is there. Okay. And output is a play. Correct. So in outlook, we are having different categories, right? Sunny is there, overcast is there, rain is there. In humidity, we are having 2 values, high and normal. In wind, we are having 2 values, weak and strong. Yes. Is it okay? Data set is done.
Yes, sir.
Do you get these 14 values? We are given the 14 days records. 14 days records. Suppose on day 11, outlook is a sunny, humidity is a normal, and wind is a strong. So there will be a play. So this model this information we are going to provide a model. And in future, if I am asking, outlook is a rain, humidity is a high, and wind is a weak, what will be there? There will be play or not, that model should give us. But how this problem will work for a decision tree, how this will work for the decision tree, that we are going to see now. Is it like problem statement clear? Yes, do you get this? What we are going to do?
Yes.
How many features are there? How many input values are there? 3 input values are there, right? Outlook, humidity, and wind. Is it? Outlook, humidity, and wind. These are the 3 input features. In that, different categories are there, right? Gender, male and female, 2 categories are there. Yes. Just like that, in Outlook, we are having 3 categories. Done? In 10 examples, how many days it is yes and how many days it is no?
9 days is
In training example, 9 days are saying there will be a play, 5 days are saying there will be no play. Correct? So we'll see how it works. So let's see how probability of yes and no will work for this. What feature model has selected first? It has selected outlook, right? 3 options are there: outlook, humidity,
wind.
and
Wind.
right? So what it has selected, outlook is selected. It could be selected like humidity. It will work with wind as well. Huh? Anything can be selected. Randomly it is selecting one feature, and on that it is working. So for outlook, what is the scenario? Root node scenario is for whole data set, for whole population. How many yes and how many no's are there? And 5 no's are there. Till what it should work? Particular feature, it should be like this. If I am having 14 points, it should be 0, 14 or 14, 0. If I am having at node, I am having 4 points. 4 different values I am having at node, it should be 4, 0 or 0, 4. Everything should be yes or no. Okay, completely yes or completely no. So how many features are there? Like how many categories are outlook? Sunny, overcast, and rain. So just check. Whenever outlook is a sunny, what scenario data set? Whenever outlook is a sunny, so 1, 2, 3, 4, 5. 5 records are there. Those are having outlook as a sunny. And just like summarize this. No, no. Then there is something called as again There is a no play, yes play, and yes play. So what will be there? And D9 having outlook as a sunny. Other two features are kept as it is. So what it is saying? If outlook is a sunny, there will be how many records are saying there will be a play? 2 records. And how many records are saying there will be no play? 3 records. Is it pure split? Is it pure split? No, right? We can't say whether there will be a play or not. Yes. Yes,
Yes, sir.
based on this situation, can you say like there will be play or not? We can't say, right? Outlook is a overcast.
Yes, sir.
If outlook is a overcast, what it is saying? Overcast, yes. Overcast, yes.
Yes.
Overcast, yes. There are 4 records. Those are having outlook as a overcast. So what is the scenario? I am having 4 records for overcast, and all four records are saying yes. And there is no record in a training data. So it will be 4-0. Done.
Yes, sir.
Similarly, for remaining, so how many records are there for sunny? 5 records. For overcast, 4 records. For rain, how many records will be there? 5 records will be there. Among those 5 records, what it is saying? Whenever there is a outlook as a rain, then 3 years and 2 nodes are there. So among these 3 situations, just take a look. 2 years, 3 nodes, there is a need of a split, right? 3 years, 2 nodes, there is again need of a split because it is not giving us a picture, like clear picture, what can be there. When it will be clear, when it is a 5-0 or 0-5, then there will be a stop of splitting. So this is 4-0 is a pure subset or pure subsplit. There will be no splitting further. But we need to work on a sunny and rain outlook with next feature. What is the next feature? Next feature is a humidity. So compare sunny as outlook, the humidity. The records are right. How many? 5 records are there. Those are saying 3 and 2. Correct? Here it was, sorry, 2, 3. Correct, no? 2 yes and 3 no's are there, right? No? Is it?
Yes, sir. Yes,
Yes,
sir.
sir. 2 yes and 2.
2 yes. For 5 it is like this. And for this 5 it is 3, 2.
3.
Correct? And this is 4-0. So it's done. For 4 to 4-0 it's done. It will no splitting. When humidity is high, so humidity again we are having 2 categories. Humidity is high, outlook is sunny. So there will be no play. What is from where we are getting this? When humidity is high, outlook is sunny. 1, 2, high, humidity, outlook sunny. How many records are there? 3 records are there. All 3 records are saying there will be no play. When outlook is sunny, humidity is a normal. Outlook sunny, humidity normal. Outlook sunny, humidity normal. 1, 2. 2 records are there. There will be a play. So how the like distribution will be there? Distribution will be like this, right? Yes. When
Yes,
humidity is high, outlook is sunny. 3-0 is there, and this is 2-0, and this is 0-3. Correct? Is it not? It is not 3-0. It's a 0-3. Correct? 0 yes, 3 no. 2 yes, 0 no. So if I'm having values like humidity, outlook sunny, there will be no play. When humidity is normal, outlook is sunny, there will be a play. Okay, that can be the prediction. Similarly, if I'm checking when wind is weak and outlook is a rain, there are 3 records. All 3 records are yes, and this is again it's the pure split. There will be no splitting further. I hope you got the idea how decision tree will work or how it is working. Yes, this is how it will work, right? But on what basis it will be decided? So final decision tree will be like this. Look, how many records were there? 9, 5, correct? 9 yes, 5 no's. How these 9, 5 yes, 9 yes and 5 yes are distributed? Sunny outlook 2-3, forecast outlook 4-0, rain outlook 3-2. Again, sunny is compared with the humidity 0-3. So there is a no play, yes play, no. What is asked on a 15th day? Outlook is a rain. What is outlook? Outlook is a rain, right? Outlook is a rain. humidity is, so rain is not compared with the humidity, but wind is compared with the humidity. Wind is a weak, correct? Wind is a weak, outlook is a rain, then there will be a play. If somebody asks you sunny, outlook is a sunny, humidity is a high, and wind is a weak, how you can say outlook is a sunny, outlook sunny, humidity high, there will be no play.
No
No.
play.
Are you getting this? I hope you got this with the help of example. How decision tree will work, right?
Yes,
It will
sir.
select the different features, and on that basis, it will.
Sir,
How? Yeah, please go ahead.
sir, can you move to previous slide one, sir? Previous one, sir. So here in wind, we are having weak and strong wind.
Correct.
Yeah, okay, okay, sir. Actually, humid is different, no, sir. That's why I'm thinking the wind is
Ah,
same.
and
Okay, sir.
again, please remember, it can be vice versa. Sunny, wind, and rain, humidity. You will get a same like similar type of accuracy only. It is not like that humidity will be this side and wind will be this side. It may vice versa in actual practice or like whenever you are working. What could be there? Like it can go to the one more level, one more step. If you are not getting, suppose in this case, it is like suppose for this one again 3 points are there, and for these 3 points it is 1 2 1 yes 2 no. Again it will go for a splitting, it could be there, right? But these features are selected randomly based on the entropy. Okay, so how these are selected, that we will see how to select the right feature or how model is selecting the right feature. So for that it is using the entropy, which measure the homogeneity of examples. What is the meaning of homogeneity? Entropy measures the impurity of a collection of example. Impurity, that means how much is the error? When will the impurity high? Suppose I am having 14 records, okay? If it is 7 7, it could be 14 0, it could be 13 1. When error will be less? When it is completely or purely splitted, right now? Whenever it is 14 0 or 0 14, this that will have a less impurity. Is it? That will have a less impurity. Are you getting? That is a
Yes,
pure
sir.
split. Correct. So it depends from the like distribution of random variable p, which is the proportion of a positive sample or negative sample. So for that we are having entropy formula. Entropy F is equal to minus or negative of probability of yes sample minus probability of no sample into log to the base 2 probability of no sample. So P plus, that is a proportion of positive samples or positive examples in yes, right? And if we use the formula for 14 0, 14 yes and 0 no, 14 yes and 0 no, what will be the formula? 14 upon 14, right now? Yes, how many total samples are there? Yes is equal to 14. Total samples are 14. Yes value is, that is positive value is 14. Negative value is 0 over here, right? If you put the values in this equation, what you will get? 0 impurity there. 14 0 and 0 14 will give you the 0 entropy, correct? Again 9 5, if I take a 9 5, it will give some value, that is a 0.94. Okay, so it will have some value of entropy, it will have some value of entropy. And if it is completely half, we can't say anything, 7 7 50 50%, so impurity will be high, that is a 1. So 0 to 1 range it will have 0, that means a less impurity or no impurity or no entropy. So what is the expectation? Entropy should be less, correct?
Yes, sir.
If entropy is less, your splitting is a proper, correct? 14 0 0 14, whatever. If you are getting like suppose 100 samples are there, and if you are getting 100 0 or 0 100, that is a pure split, right? Whenever it is splitted, correct, whenever it is splitted, some information is gained over there, right? Suppose initially it was a 9 5, then 14 samples are distributed like this 9 5, or initially it is a 7 7, Then in second step, 9, 5. And in fourth step, suppose 14, 0. So some information is gained over here about a class, right? So initially it was a 7 yes, 7 no. Now what it is saying? Now it is saying out of these 14, 9 yes are there, 5 no's are there. And what in last step, what it is saying? 14 yes and 0 no's are there. So step by step, what you are getting? You are getting the maximum information about a class. Which class? Yes class. Correct? So finally you are getting 14, 0. That means you are getting the maximum
So what if
information
we
about a
never get
class.
it? What
Yes.
if we never get a zero? If, for example, sir, if there is some if the data is like that, even though if it's humidity is there, wind is there, but once he went and once he didn't go, so it will never become zero. Then it
So
might
it
happen,
will,
no, sir, according to the
it
data.
will, it may happen, but what it will do, suppose what we are selected initially, we are selected Outlook, right?
Yes, sir.
Outlook 3 categories. Then there is done with this, right? Forecast done. Next, what we have selected sunny with humidity, correct?
Yes, sir.
Sunny with humidity. And last feature remain, that is only 3 features are there. Only 3 features are there. And humidity can be checked with wind again. Last option, right? After wind, if we are not having any choice, correct? After wind, we are not having any choice. And for wind, it is 5 records are there. For wind, how many records are there? 5 records are there. So it can be 4, 1, 3, 2. Most of the cases, it will be 5, 0. It will try to reach a 5, 0, but it may be a 4, 1. So here, it will not be zero entropy, obviously, but it will be something like this 0.10, 0.20, which is less. It will not be 1. In what case it will be 1? 2.5, 2.5, or 3, 3 for 6. Then it will be a 1. So less entropy it will consider, or like based on the majority of a class, if we are not having any further attribute. But it will go step by step only, right? Initially it was a 9 yes, 5 nodes, and till what step you are getting? 3, 0, 2, 0, 2, 0, 3, 0, till that step you are like distributing that. And the tree will grow. The growth of a tree will be there until and unless you are not getting the less impurity or less entropy. Yes.
So entropy will range between 0 to 1 only, sir. Only in between 0 to 1.
0 to 1, correct. 0 to 1. 0 that is a no entropy.
Yes.
1 that is a 100% entropy, like impurity is there. If you are
Okay.
checking, if you are putting the values in that equation, if you are putting same values, you will get a 1. If you are putting a 5, 0, 5, you will get a 0. If you are putting 0, 5, you will get a 0. Okay, this is how it will work. Okay, so information
Yes.
gain aims to reduce the level of entropy starting from the root node to the leaf node. Okay, root to leaf. Impurity will get reduced, information gain will be
More.
increased. Right? Information gain means it is taking, like it is telling about a class. Correct? So entropy and information gain, these are the vice versa. Entropy is reducing, information gain is
Increasing.
increasing. Okay, so this is how it will work. Last, like again, one more choice is there for a criteria, just like a entropy. Another one is there, that is a Gini index. So it is again same, Gini index or a Gini impurity measure the degree of probability for particular variable. Formula is like Gini index is equal to 1 minus summation of 1 to n pi square. Pi square, that means simple, probability of yes square plus probability of no square. 2 classes are there, and if you are like taking the value of those probability of yes square 2 by 4, right now, if I am having 4 records, and out of those 4 records, if it is a 2 2, so 50-50 chances are there. So Gini index I am getting 50.5. Okay, and if I am putting those values in this equation, square of suppose 0 upon 4, if it is, these 4 records are distributed like this, 0 comma 4, 0 yes and 4 no's are there, square plus 4 upon 4 square, 1 minus 0 plus 1, So 1 minus 1, it will be 0. So whenever Gini index or entropy is a 0, there will be pure split. Yes, is it okay?
Yes, sir.
This is how it will work, right? So if you talk about like pros or advantages of a decision tree, it's easy to understand. It is just a tree like a structure. While giving the implementation, we'll try to build it. Okay, decision tree output is very easy to understand, and even like people from non-analytical background also, non-data science background also, they can understand. Does not require any statistical knowledge to read or interpret the results. Okay, as compared to other models, less data cleaning is required. So it's a tree-based algorithm. Initially, whatever we have covered till now, those were the distance-based algorithm. Now it's a tree-based algorithm, and it is less influenced by outliers and missing values. And data type is not a constant, can handle both numerical as well as categorical values. And tree versatility is there. So it can be customized for a variety of situations. These are some advantages. If we talk about like cons or disadvantages or limitations, overfitting is a major issue in a decision tree. If tree grows like without stopping, okay, so it can go for like any level. So there will be like a good learning, good training, but while testing the result, it is facing the challenges. That's why overfitting is there. Low accuracy for continuous variable majorly is used for the major use cases for classification. Okay, so they are unstable. Like a small change in a data can result the large change in tree structure. Okay, that is major disadvantage again. Application you can find in any field: medical diagnosis, credit risk management, whether person will stay with you or not, recommendation system, business decision, loan approval. Okay, manufacturing, education, movie recommendation. Everywhere you can find the application. So these are the some things related to a decision tree. We'll try to implement the model tomorrow for this. Okay. Is it clear? Any doubt?
Yes, sir.
Yes.
No, sir.
Any doubt?
No, sir.
Okay. Thank you guys.
Thank you, sir.